Good day, everybody. How are you all doing? Today we are going to discuss about frequency distributions and their graphs. So here I go. Let me, give me a minute and I'll be there. This is it. Frequency distributions and their graphs. We already talked about frequency distribution in the previous presentation. So you know, in categorical data, we can divide the data into different categories and then look for how many times each category occurs, which is frequency. So here we are going to discuss about frequency distributions and their graphs. Construct Previously, we dealt with qualitative data. Now we are going to deal with quantitative data, numbers, but the same idea. Construct histograms, that is frequency on the vertical axis versus data on the horizontal axis. Now the data will be divided into groups or classes as you will see. Describe the shape of the distribution from a histogram. Construct frequency polygons and ogives. These are not ogives, these are ogives. Construct frequency distribution for quantitative data. Again, to remind you, quantitative data is something that we count or we measure. Okay, most likely we are measuring. So here is the data. To summarize quantitative data, we use a frequency distribution just like those for qualitative data. However, since these data have no natural categories, we divide the data into classes. Classes are intervals of equal width that cover all values that are observed in the data set. For example, the first class is between 0 and 4. The lower value is 0 of called is the lower class limit. The upper value of 4 is called the upper class limit. Okay. The next class starts from 5 to 9. Notice the frequency or the count in the class between 0 and 4 is 2. That means in the original data, which we do not see here, there are 2 points between 0 and 4. Similarly, there are 4 points between 5 and 9. Okay, so what is the class width? The class width is the lower class limit of the second class, which is 5, minus the lower class limit of the first class, which is 0. 5 minus 0 is 0, as shown in the diagram. It is not 4 minus 0 equal to 4 or 9 minus 5 equal to 4. However, it is equal to 5 minus 0 equal to 5, or 10 minus 5 equal to 5. So choose a class width. These are the steps. Choose a lower class limit for the first class. Compute the lower limit of the second class by adding the class width to the lower limit of the first class. Compute the lower limit for each of the remaining classes. Stop when the largest data value is included in a class. Count the number of observations. So here we go. So these are emission of particles coming out from the exhaust tailpipe of cars. And I believe these are in milligrams per mile traveled, something like that. So construct a frequency distribution using a class width of 1. Now, first we will look for the lowest value in this data set. And I believe if you look carefully in the last row, horizontal row of data, last row, fifth row, the first data point is 0.25. That is the lowest. And similarly, we look for the highest. Highest is occurring, let's see, if we go in the fourth row, the one before the last row, the highest point is somewhere towards the right side, is 6.55 on the fourth row. Okay, so since the smallest value of the data set is 0.25, as I indicated, the we choose 0. Why did I choose 0? Because it's slightly below 0.25. So if we start a class with 0, it will include the value of 0.25. Now we have been told that the class width is 1. So that means 0 plus 1 is the lower class limit of the second class as shown in this diagram. Then 1 plus 2 is 2 and so forth. 2 plus 1 is 3, 3 plus 1 is 4. These are the lower class limits or the left class limits of each class. Now, how do you construct the right class limit of each class? Now, you know the lower class limit of the first class is 0, lower class limit of the second class is 1. Now, also we notice that the data set is in two places of decimal. So, the upper class limit of the first class will be slightly below 1 and it will consist of two places after the decimal. Therefore, we choose to stop the first class or the upper class limit of the first class, we keep it at 0.99. Okay, and then we keep on adding the class with the 1. So the upper class limit of the second class is 1.99. Upper class of the third class is 2.99. How do I get 2.99? I get 1.99 from the second class upper class limit, then add a class with the 1 to it to make it 2.99 and so forth. Then we went to the actual data set and counted how many numbers are in each class. For example, in the first class, which is between 0 and 0.99, the count is 9. The second class, which is between 1 and 1.99, the count is 26, so forth. If we add the frequencies, it should add up the sum of the frequencies of each class. If we take all the classes and add the frequencies, it should add up to the sample size. And then we divide frequency of each class by the sum of all frequencies, or divide into frequency of each class sum of the frequencies to get the relative frequency. Again, what is the advantage? You know 40% of the data are between 1 and 1.99. So the majority is in the second class. And then we can construct a histogram once a frequency or relative frequency distribution. So this table is called a relative frequency distribution. It is not called a relative frequency distribution table. It is just relative frequency. And it says once a frequency or relative frequency distribution has been created, the information can be put in graphical form by constructing a histogram. Histograms used for quantitative data. They are related to the bar graphs, which are used for qualitative data. One big difference between the qualitative data and quantitative data histogram or the bar chart, you see in this vertical bar chart, there is no gap. Whereas if you remember in the class of the credit cards, there was a gap between MasterCard and Visa on the horizontal axis. Here, there is no gap between the classes on the horizontal axis. And what the height is equal to the frequency occurring in that class or relative frequency. The class width is the same. Remember, 1 is the class width in this case. Hence, the class width is same of each of the bars. The frequency histogram and relative frequency histogram are given for the particulate emission data. Note that the two histograms are the same shape. What is the difference? One on the left in the vertical axis, the actual frequency of the count. The one on the right, relative frequency on the vertical axis. The number of classes can affect the shape of the histogram. Too few classes produce a histogram lacking in detail. Too many classes produce a histogram with too much detail, as one on the left, and so that the main features of the data are obscured. So you don't want too few and you don't want too many. So what is the cardinal rule? Somewhere between 5 to 6, 7 maximum, maybe. And we can do it with TI-84 plus. Okay. Only thing, we do not have any control on the class width on the horizontal axis. TI-84 by itself will on its own will choose the class width. Okay. It is sometimes necessary for the first class to have no lower limit or the last class to have no upper limit. Such a class is called open-ended. Notice the one at the bottom of this, 85 and older. It does not stop at 94, for example. contains an open-ended class, a histogram cannot be drawn. So do not attempt to draw a histogram because the last class in this case does not have a end. It's an open-ended. So this is frequency distribution presents the number of deaths in the US due to pneumonia for various age groups. Note that the last age group is 85 and older, which is an open-ended class. This is a histogram of discrete data. Point to note here, because there are no groups in number of children, what do we have? We go from 0 to 1 in the first class. With actually, in most textbooks, they show the middle of the first bar to be 0, which has a frequency of 435. Remember, this is number of children. So 0 is the midpoint on the horizontal axis of the first bar with a height of 435 because the count is 435 in that class. Then 1 is the midpoint of the second um, bar, and its height is 175 as shown in the table, and so forth. Shape of the distribution from a histogram. What we'll do first, we'll look at the class with the highest height or the highest relative frequency. The one on the top, the highest relative frequency is on the extreme left. Then you look to the right of it, most of the data are to the right of it. So there's lot of points, higher value points on the horizontal axis. Hence, this type of histogram is called positively skewed or right skewed. On the one on the bottom, you look for the relative frequency highest on the extreme right class. And then there are many data points below it. So it is heavy on the smaller side, smaller data side. So it is left skewed or negatively skewed. And histogram is symmetric. If symmetric means it's like a mirror in the middle, the left half is equal to the right half. And the one on the top is approximately bell-shaped. It's not 100%. But if you think of the class in the center, which is highest height or relative frequency, the area to the left of it is equal to the area to the right of it. So it's approximately bell-shaped. Okay. And one on the bottom is uniform, almost uniform. Why? Because the height of each of these rectangles are almost similar, not exactly similar, almost similar. So almost uniformly distributed. Uniform distribution means same relative frequency of each class. So unimodal means there is only one uh, class, in this case one in the center, which has the highest relative frequency. So the number in the center between 2 and I don't know 2.3 or whatever, in the center on the horizontal axis, that class has the highest relative frequency. That means that number appears with the maximum frequency only one mode, unimodal. Whereas if you look at the one on the right, there are two classes, one on the left, one on the right, that have the same height. So because these two numbers appear with the same mode or same percentage relative frequency, bimodal. Bi means two. It has got two modes. Classify each of the one skewed to the left. The one on the extreme left, top left, is skewed to the right. You look at the class with the highest relative frequency, highest height bar. Look to the right of it, more numbers on the right of it. So it's positively skewed or right skewed. The one on the top right, left skewed. The one on the bottom left, almost uniform. And one on the uh, bottom right is almost symmetrical or almost bell-shaped. The one on the top left is unimodal. The one on the top right is also unimodal. The one on the bottom center is bimodal. Construct frequency polygons and ogives. Some graphs are used for representing frequency or relative frequency distribution are called require class midpoint. What is the midpoint of the class? It is the lower class limit of the first class divided by lower class limit of the second class. You add them together to the two or lower class of adjacent classes. add the two lower class limit and divide by 2. This is the class midpoint. So for example, the class midpoint of the first class in this table is 0 plus 1 divided by 2 is 0.5. It is not 0 plus 0.99 divided by 2. It is the lower class limit of the first class, which is 0, plus the lower class limit of the second class, which is 1. 0 plus 1 is 1, divided by 2 is 0.5, and so forth. A frequency polygon is constructed by plotting a point for each class. The x-coordinate of the point is the class midpoint, and the y-coordinate is the class frequency. For example, the first point on the left in this diagram, frequency polygon, x value is 0.5, y value is 9. The second one, x value is 1.5, y value is 26, and so forth. And cumulative relative frequency, you just add the frequency of the class before that. So you start with the first class, which is between 0 and 0.99. The frequency of that class is 9. There is nothing on top of it, 0 on top of that class. 0 frequency on top of that class. So 9 plus 0 cumulative frequency is 9. Whereas if you look at the second class, frequency of that is 26. On top of it is 9. 26 plus 9 is 35. Look at the third class, frequency is 11. On top of it is 35. 35 plus 11, 46, and so forth. And ogive is a plot of cumulative frequency versus upper class limit. The x-coordinate is the upper class limit, and the y-coordinate is the cumulative frequency. Okay, so this is called an ogive. Okay, so that's the end of it. If you have any question, send me, and you can always ask me a question. If you like this video, give me a thumbs up. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. And please let YouTube know that you like to be notified every time I upload a new video, which I do almost every day. And I look forward to seeing you next time. Please do not forget to watch me tomorrow when I'll be back with another interesting presentation. Thanks for watching. Have a nice day. Take care. See you.